Exercise 2E. Review of matrices. Shh. Listening. Now, in terms of skills, so you realize skip A, we did B, C, linear equations, literal equations. Skip D, we jump into E, and E is review of matrices. So you learn basically everything here is prerequisite knowledge. It's Unit 1 and 2 general maths. That's what you need to be able to do in order to move on to 2F, which is what you're going to get assessed at the end of year. But you can't do 2F unless you knew your general math stuff. Okay? So, you need to know how to add, subtract, multiply, find inverses, and solving systems of linear equations of matrices, using matrices. Okay? In methods, you will also need to be able to apply matrix transformations, and that's what they'll be checking. So they'll be looking for matrix transformations, and they'll be looking for whether you can solve linear equations. Okay? So let's have a look at refreshing some skills. All right? Some of which you might already learn from Spesh. For those who haven't, then we're going to revise them all. Okay? So review of matrices. I want you to copy this down. Matrix dimensions. When we say matrix dimensions, it's just how we tell you how big a particular matrix is. So we normally say it's M by N, and that represents rows by columns. Okay, so when we say M by N matrix, M by N matrix represents rows by columns. When you're adding and subtracting matrices, they must have the same dimensions. Meaning if it's a 2 by 2, then you have to make sure that you're adding a 2 by 2 with a 2 by 2. So 2 rows, 2 columns with 2 rows, 2 columns. You cannot add matrices of different dimensions. For example, let's say I gave you 2, 3, 1, 4. This is a matrix of 2 by 2, so 2 rows by 2 columns. If I wanted to add this with, let's say I made another one and I said 1, 4, 5, 7, 1, negative 2. See, the issue with adding is you can't add the coordinates. You can't say, well, row 1, column 1, you can probably add it with this one, row 1, column 1. But then where do you add these values? Because this would be row 3, column 1. For 1, there is no row 3, column 1 in this one. That's why you can't add them. That's why the property says matrices need to have the same dimensions. If you have the same dimensions, you can correspond each coordinate with each coordinate. Or if you think about it, positions rather than coordinates. Okay, so positions, you have to have the same dimensions for them to add. Add or subtract values of the same position, so I use R1, C1 to represent row 1, column 1. And then row 1, column 1. Okay, now multiplication of matrices is what you need to remember as well. And there are a couple of properties in here. AB, so matrix A multiplied to matrix B, is not the same as matrix B multiplied to A. Okay, so this is not like your general numbers where 2 times 3 is equal to 3 times 2. Because we're dealing with matrices, it's a different set of how do you multiply matrices. And so when you switch it, it actually changes your values. Okay? And of course I wrote here, unless B is the inverse of A, which we'll talk about inverses, and I want you to understand what an inverse is, because once you understand what you're really doing, matrices chapter 2 is so easy. Okay, we'll knock it all down. Now I'll try to explain this double session so that you have a better idea of what you're actually doing when you're doing the inverses. Okay? Can only multiply if, now this one most students may forget, but after you do a couple you'll remember it. Column of matrix A has to equal to the row of matrix B. So what am I saying? Let's say matrix A was A, B, C, D, E, F. This is a 2 by 3. 2 rows, 3 columns. So 2 by 3 matrix. So I said the column of matrix A, so the column which is 3, it has to equal to the row of matrix B. So whatever my matrix B is, it has to be 3 to begin with. Okay? If it's not 3, you can't multiply that. So this, which I'm going to highlight so you can see, column of matrix A multiplied to B, regardless, the row has to be the same. So these two have to be the same. Okay, so I have, let's say it could be 1. That works. You can multiply those two. So what's a 3 by 1? You could have 1 column and it could be D, E, F. Okay, that could be 3 by 1 matrix. So 3 rows and 1 column. And you can multiply those two. Okay, you can multiply it by a 3 by 2. So it would be F, G, H, I. That's fine as well. Nothing wrong. So we need column of matrix A to equal to the row of matrix B. If I change these numbers, and even if this is a 3, and this is a 3, and I keep this as a 4, so what's a 4 by 3 look like? Let's say 4 rows, A, B, C, D, 4 rows, 3 columns, E, F, G, H, I, J, K, L. This one you can't multiply. Okay, so when you have different row versus a different column of matrix A, then you can't multiply those two. Okay, so those two have to be the same. Next one. When you multiply, how do you multiply matrices? In order to multiply matrices, you are going to multiply row 1, column 1 with row 1, column 1 of the other one. So for example, if I had, actually I'll show you in the other example later. Okay, just write that down. Multiply via position. So row 1, column 1. And I'll show you this in the next example. All right? Matrix inverse, this is what I really want to get through, because you understand that, then that links to solving linear equations, which is what you're required in year 12. You need to understand what matrix inverse is, and I'm going to spend some time talking about that. Okay? Inverse matrix is like the opposite operation of matrix multiplication. Now, if you didn't know, with matrices, there is no division. Okay, there is no division. You can't divide matrices. So you can't say matrix A divided by matrix B. We don't have that. Okay, we've got add, we've got subtract, we've got multiply, but we do not have division. Okay, and that's why you need to learn the inverse in order for you to solve your X matrix. Okay, and it'll make more sense when I get to the next few pages. Okay? And then this is where, if you don't understand what an inverse is, you're going to end up memorizing this here. Okay, so inverse will exist if det, which stands for the determinant of A, doesn't equal to 0. Now, a lot of students will forget and think it's equal to 0, and sometimes they just let it equal to 0 and they don't know what they're doing. You have to understand why det of A can't equal to 0, and I'll show you why. And the determinant of matrix doesn't equal 0, and why that tells you something. Okay, and if you remember from last year, if any vague memory, it talks about infinite solutions, unique solution, or no solution. Okay, and I don't want you to memorize all of that. I want you to understand it, and once I show you, it will make a lot of sense. You won't memorize it. You just got to think of 2 straight lines, and it will totally make sense. Okay, so copy that down. Matrix inverse and matrix multiplication are the things that I'm more interested in. Exercise 2E, adding, subtracting, you'll find that real easy. Okay, I'll do a couple examples and then I'll get to these 2 ideas. Okay, here we go. Just in case you've forgotten what determinant of A is, determinant of A, you can find that by multiplying AD minus BC. What is AD minus BC? Traditionally, we represent your matrix as A, B, C, D. So the determinant of A is equal to A times D in those positions. Row 1, column 1 multiplied to row 2, column 2. Subtract row 1, column 2 multiplied to row 1, column 1. I mean row 2, column 1. Okay, that's what this determinant is referring to. Now, let's do an example. Addition, real simple. So the first thing I said was adding and subtracting, you have to have the same dimensions. Now this is 2 rows by 2 columns. So 2 by 2 matrix. This is also 2 rows, 2 columns. So yes, they are the same matrices. Now you can add them. How do you add them? Positions. This is row 1, column 1. So row 1, column 1 is 2. Row 1, column 1 for this one is -2. So when you add them, you are literally adding. Oh, it's not coming up. Why is it so slow? Oh, it's frozen. Let's wait. Huh. I think it's so hot today, I think it's sort of slowed down.